All right, hey y'all. So I am going to go through five different types of reactions, and I hope you pay attention. I know for a lot of my students that are watching this, that means you did not come to school, and so now you have to make it up. And so for those of you that are not my students, I hope you take something away from this. All right, so we have the five different types of reaction. But before we get started with the different types of reaction, I want to go ahead and break down the parts of a chemical equation. Now, this is so important for you to know because there are three different parts to a chemical equation, okay? So, first you have what we have, which is the reactant, all right? That is what the reaction starts with. All right. Then next you have the yield sign. The yield sign is not an equal sign. Okay. The yield sign is not an equal sign. It is an arrow that separates the reactant from the product. And then lastly, you have your products, and that is what the reaction ends with. All right. All right, so there are five different types of reaction. Today we're going to talk about synthesis, decomposition, single replacement, and double replacement. So I'm just going to leave this up on the screen just for a little bit. That way you can write this down. I highly suggest that you take notes. I know for me, my students, y'all already know, you must have your composition notebook. So I highly recommend, if you don't, just get something that you can write down with it. And if you're in my class, have your composition notebook and take your notes down in this. All right. All right. So I am going to break down. Oh, also, this is the fifth one. Composition. Composition is the fifth one. All right. All right. So here, oops, let me go back. So we have a synthesis reaction, okay? So a synthesis reaction, there's two ways that I'm going to break this down to you. And I just use this as a strategy. I like to tell my students, I'm like, okay, I'm going to tell you the scientific way, and then I'm going to give you the non-scientific way. More of a way that's more relatable, in a way that it doesn't have all the scientific terminology so that it can stick with you. This is a strategy that you can use on your exams as well, all right? So when it comes to a synthesis reaction, okay, the scientific way is to say that it is two or more substances that combines to form a new substance. So for an example, we have H2 plus O2. Okay, so we have H2 plus O2 that is found in your reactant, that is found on the left side of your equation. And then what you have produced on the right side of the equation is H2O. So these two substances come together on the reactant side, and then they create an actual substance, or what we like to call in science a compound. Okay, so H2O plus O2 comes together and it creates H2O, and that is when you have a synthesis reaction. Now, that is for those of you that understands things on a scientific level. Now, for those of us that need a little bit more of a breakdown, you have here, you have Barack Obama, who will be considered a single element, okay? So at some point in his life, he was single. And then you have Michelle Obama. She would be another single element. So in the reactant side, both of them were single, okay? And then on the product side, they end up coming together and they end up becoming a couple, which in scientific terms, we will consider that a compound. So Barack will be considered our H2. Michelle will be considered our O2, and then in our product, they come together to create one compound, which is H2O. All right. Next type of reaction, we have a decomposition reaction. All right. So, in the scientific terms, that is when you have one compound that starts in the reactant, which here we have NaCl. So, in the reactant, what our compounds, or what our reaction starts with, is a compound that is together. But in the product, they split apart. Okay. They split apart. So now you have Na by itself, and then you have Cl by itself. Now, on a more non scientific matter, you have a couple that starts out together in the reactant. That is what the reaction started with. So we have Kim and Kanye, and they started off as a married couple, okay? But then things happened, and what was produced is that in the end, they broke up, they split apart. So I like to say to my students, okay, with a decomposition reaction, this is the breakup reaction. The breakup reaction. They broke up. It just didn't work out. All right, next we have the single replacement, okay? So we have a single replacement. The single replacement is when you have one element replacing another element. Ooh, child, okay? This is where things get a little funny, all right? So, in the scientific manner, you have typically what happens is that your metal, right? So, when you have an ionic bond, this is a quick, I'll have another follow up video, but in your ionic bonds, okay, your metal and your non metal, you have a metal and a non metal that comes together. Your metal always comes first, and then you have your non metal. However, in a single replacement, your metals always stay in place and you replace your non metals, okay? So as you can see here, we have Ki, K being our metal and I being our non-metal, plus Cl, which is another non-metal, okay? So I already know from here that in my reactant, I only have one metal and I have two non-metals. So from there, I'm going to have a swap of my non-metals with my metals that is going to create a single replacement. All right, so that is how I know that I have a single replacement on a more scientific term. Now, for my people that didn't understand the scientific way, no worries, I got you. So here we have Kim and Kanye. Again, they started as a married couple, all right? So we're following the Kim and Kanye story. So they started as a married couple, and at the time that they were married, there was a single woman, and I believe her name is Bianca. So she was single at the time that they were married, okay? And when I say single, I mean not married. Um, and so then what was produced once Kim and Kanye broke up, Kanye then married Bianca and now Kim is single. So now there was a replacement, all right? A replacement happened in this case. So one of the elements were replaced with the other. So in this case, the women will be considered our non-metals because our non-metals is what's being swapped, okay? So Kanye will be considered our metal. He stayed in place and he swapped partners, all right? I hope that makes sense. It's a little juicy. Okay. Next, we have a double replacement. Okay. Now, double replacement is when you have your positive ion of one compound and it replaces the other positive ion of another compound. All right. So here, for an example, we have Na, which is a metal, which will be considered our positive ion, paired with Br, which is our negative ion. Then we have Ca, okay, which is our positive ion, paired with OH, which will be considered our negative ion. All right, so we have that in the reactant. Now, when we go over to the product, we see that our positive ion has now swapped out with Br. Okay, so that was our non-metal. So previously, Br was paired with our non-metal with our positive ion, which was Na, but now it has switched to the other positive ion, which is Ca. And then you have Na, okay, that has been swapped out and paired with OH. Okay, so I'm gonna give y'all some time. Maybe you need to pause, run it back. All right, now I am going to share what that looks like in a non scientific example. Okay, so you have this couple right here. All right, so they started off in the reactant, they started off as a married couple. These two right here, they started as a married couple. And then these two right here, they started as a married couple. All right, in the reactant side, this is what the reactant is what our reaction starts with. All right, but then things happen. All right, and then they swapped partners. Okay, they swapped partners. So this gentleman here, he's no longer with this lady and he ends up being with this lady, child. Ain't that crazy? And then this couple ends up swapping partners to where this gentleman end up being with this woman, all right? So they literally swap partners, okay? So as you notice, we have NABR, okay, the example that we used earlier, all right? So NABR, so NA will be this gentleman right here, BR will be this young lady right here, CA will be this young lady right here, well, actually, no, CA will be this gentleman, and then OH will be this young lady right here. And as we can see, the metals, the men stayed in place, right? But then they swap partners. So they swap wives, okay? So that will be what a double replacement looks like. Now, I like to tell my students, and I would like for y'all to see that the breakdown of this is that for a double replacement, when you look at your reactant, you will notice that double for one means two. So when you have double, it means two. So you will notice that you have in your reactant two couples, or what we like to say scientifically, two compounds. So you have NABR and then you have CaOH2. All right, so you have two couples. When you have two couples in your reactant side, you likely are going to deal with a double replacement. All right. And then lastly, you have we have combustion. All right. So for combustion reactions, all right, a combustion reaction, this is the easy one. You have CO2 and H2O in the product. Okay. So if you look here, we have our reactant here on the left side of our yield sign, and then you have your product here, the right side of our yield sign. CO2 and H2O is what is produced in a combustion reaction. There is no combustion reaction if there is not both CO2 and H2O in the product. All right. So CO2 and H2O has to be in the product in order for it to be considered a combustion reaction. So I have an example here, right? Right here we have HCl plus NaOH. And in the product, we have H2O. And a common mistake that is made is that most people, they will see that H2O is in the product and they will assume that it's a combustion reaction. However, it is not considered a combustion reaction if it does not have both CO2 and H2O in the product. So here we only have H2O, which makes it not a combustion reaction. Okay? It must have CO2 and H2O in the combustion reaction or in the product in order to be considered a combustion reaction. So I hope this helped. If you are taking my pre-AP chemistry class, okay, you need to make sure you're taking your notes in your composition notebook and then making sure that you're transferring your notes that's on Blackboard onto your fill in the blanks guided note sheet and copying those notes into your composition notebook. I hope this helps, and I'll have more videos to come.